So now we have y equals 6x squared, and we need to get rid of y and x, so we have only r's and thetas. And I remember that y is equal to r cosine of theta. Now the x squared, that makes me think of the x squared plus y squared equals r squared. And so I could try using x squared equals r squared minus y squared, but the problem is then I have an extra y I'm putting back in there. So that's probably not the way to go. So like I did over here, I'm going to use the x equals r cosine theta substitution to get rid of that x. So I'm going to replace, so I'm starting with y equals 6x squared. I'm replacing y with r cosine theta. Then I have 6 times parentheses squared, and instead of an x, I have r, oops, I did that wrong. This is the sign up here, isn't it? R cosine theta here. I have to square that, so that's going to give me 6 r squared cosine squared of theta equals r sine of theta. And then I have to solve this for r. So maybe I'll subtract the r sine theta to the other side. And don't do something like divide by r, because if r could be 0, we just divided by 0 and we lost some information. So we're not going to do any division here. Avoid that if possible. We're just going to subtract our sine theta to the other side. So then I'm going to get 6 r squared cosine squared of theta minus r sine theta equals 0 since I subtracted that away. Oh boy, this is an ugly one. So here, if we just factor the r, we're still going to have an r stuck behind. So it looks like the only way to go is quadratic formula on this. Eek. Hang on, my brain's thinking about another idea. It's not coming. Yeah, that's the only idea I have on this so far. Let's try it, see what happens. Yeah, this is definitely a bad idea up there. That's going to make things worse. All right, let's go for it. So we have 6 r squared cosine squared of theta minus r sine theta equals 0. Did I copy that right? Looks good. And we want to solve for r. Now, just factoring an r out would leave an r behind here, and I'll still have 2 r's. I got to get this down to r equals everything else on the other side. So now I'm just going to think about the quadratic formula with r instead of x. So if I have something like a r squared plus br plus c equals 0, then r is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. So what's my a over here? So my a is everything besides the r squared here. So my a must be 6 cosine squared theta. My b is related to the r, so it would be everything by the r, so that would be the negative sine. So b is negative sine theta. And I have no plus something, so c is 0 here. So filling that in, r equals negative b, so opposite of the sine. So that's just the sine of theta, plus or minus a crazy big square root here, b squared, that's going to be the sine squared of theta, minus 4 times a, which is 6 cosine squared of theta times c, which is 0. Oh, thank goodness, that's nice, multiplying by 0. All over 2 times a, which is 6 cosine squared of theta. All right, clean this mess up. The times 0 is here because that means this whole thing is really just 0. So then I have the sine of theta plus or minus the square root of the sine squared of theta, all divided by 2 times 6 is 12 cosine squared of theta. Now, slight dilemma here. This looks really nice, square root of the sine squared. But if you think way back to pre-calculus or maybe intermediate algebra, the square root of x squared isn't x, it's the absolute value of x. So didn't they give me any hints to deal with that in the problem? Let's see, this was number 8. Nope. Damn. Okay. So then, what do we have? We now have sine of theta plus or minus the absolute value of the sine of theta all over 12 cosine squared of theta. Okay, so 2 problems. The absolute value is definitely a problem. And if we think about the sine, right, sine oscillates. Sometimes it's positive, sometimes it's negative. Absolute value of the sine would basically flip this bottom hump up, and it would do something like this. Boom, 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 boom. If we didn't have the absolute value, then we either have a plus, which would be nice. So what if we could ditch that constraint there? Then we would either have sine plus sine, which would be 2 sine over 12 cosine squared of theta. If we have the negative, we would have sine minus sine, which is just 0, always 0. If we ditch the absolute values, that means I can only play where the sign is positive, which would be like this hump right here, which is from 0 to pi interval. So, and again, they didn't give me anything else to go by, so I guess I'm going to go for this version here. 2 over 12 is 1 over 6, so that would be the sine of theta over 6 cosine squared of theta. Let's graph that and see what it looks like before we go and check anything. So let's see which one worked well. This polar one worked here. So we're just going to go in here. And we have, double check, sine over cosine squared, 6 in the bottom. So sine of theta divided by 6 cosine squared of theta. That looks like a parabola. So let's see, let's graph the parabola to check. Parabola should be 6x squared. Y equals 6x squared. Yep, they sit on top of each other. Cool. So this should be the sine of theta divided by 6 cosine squared of theta. Could we write that simpler? Don't think so. Sine over cosine is tangent, but we still have another cosine in the bottom. That doesn't make things any better. Oh, it's about as simple as it gets, I think. So this goes back to one of the points I made earlier. Some things are relatively simple in Cartesian and a wee bit more complicated than rectangular. So if I needed to mess with this for some other stuff, I would definitely choose rectangular over polar.